The rail pressure sensor is designed to convert fuel rail pressure values into voltage signals for the engine control unit. The ECM supplies a 5-volt reference and low reference to the sensor. Varying signal voltages are returned to the ECM based on fuel pressure within the rail. When the fuel pressure is high, the signal voltage is high. When the fuel pressure is low, so the signal voltage is also low. The diagnostics for these codes will run only when the engine is running and the battery level is greater than 11 volts. A P0193 will be recorded if the sensor signal voltage is higher than a predetermined level. This may be caused by a short to voltage in the high reference circuit, an open or short to voltage in the low reference or signal circuit. Having a battery maintainer connected during any electrical checks will guarantee stable voltage readings. Disconnect the harness connector at the fuel rail pressure sensor and attach a meter set on volts between battery negative and the high reference terminal. Turn the ignition on and record the voltage. The expected value would be between 4.8 and 5.2 volts. Anything over this would be interpreted as a short to voltage. If the initial recorded voltage reading from the high reference circuit indicated substantially higher than 5.2 volts, a short to voltage will be the cause. With the meter connected between battery negative and the high reference terminal in the fuel rail pressure sensor harness connector, turn the ignition off and disconnect the ECM. If the meter reading is still higher than expected, the short to voltage is in the harness between the two connectors. If the meter reads 0 volts with the ECM disconnected, the short is in the ECM or a circuit from the ECM. To isolate between the two, perform a continuity test between the high reference terminal at the fuel rail pressure sensor and all other terminals in the ECM. If no fault can be found, the short to voltage is internal to the ECM. With the rail pressure sensor disconnected, attach the meter leads between the low reference terminal in the harness connector and battery positive. Battery voltage should be displayed. To determine if there is a short to voltage on the low reference circuit, turn the ignition on and move one meter lead to battery negative with the other attached to the low reference terminal in the harness connector. Evidence of this would be indicated by any voltage reading displayed on the meter. Turn the ignition off and disconnect the ECM. Turn the ignition on. If the meter still displays a voltage, then the short is in the harness between the two connectors. If the voltage disappeared, then the short may be in the ECM or a circuit from the ECM. To isolate between the two, perform a continuity test between the low reference terminal at the fuel rail pressure sensor and all other terminals in the ECM connector. If no fault can be found, the short to voltage is internal to the ECM. With the ignition off, disconnect the fuel rail pressure sensor harness connector. Set the meter on volts and connect between battery positive and the signal terminal in the harness connector. You should see battery voltage displayed. A short to voltage would be observed if any reading was displayed when connected between battery negative and the signal terminal in the sensor connector. Turn the ignition off and disconnect the ECM. Turn the ignition on while watching the meter display. If there is now no voltage reading, the short to voltage is in the ECM or a circuit from the ECM. To isolate between the two, perform a continuity test between the signal terminal at the fuel rail pressure sensor and all other terminals in the ECM connector. If no fault can be found, the short to voltage is internal to the ECM. If, when the ECM was disconnected, the meter still displayed voltage, the short is in the harness between the two connectors. If the high reference, low reference and signal test OK, the DTC can only have been caused by the sensor. Continuous training will guarantee effective diagnosis will be reached in minimal time. Thanks for watching.